Great. So welcome to today's meeting. I would like to show you something about user classes today. We will continue in presentation of last training presented by Mirek Luňák. How to use user classes as some kind of static object which hold references for pens, fonts, and so on. At the beginning, I will start with very simple example. It's prepared on my second screen, so I will just copy paste it to the window. I hope you see my left screen. I have created a definition of two classes, cube and sphere. These are simple geometric shapes with some parameter, dimension and radius, and some properties, volume, surface, and some printing function. What I want to show you is how to work with such elements, such classes. Okay, I will try to restart. Is it okay now? Can you see my screen? Yeah, great, thank you. So again, now you should see the definition of classes.
Sorry, I don't see the screen.
Sorry?
I can see that my connection is lost, so there is some issue.
I can't understand you, Jirko.
I just see the meet now, the same for, but no screen.
I can't hear you. It's almost impossible to understand you. Try to type to the chat, please. Yeah. So we have two simple classes, and now we will use them somehow. So I have prepared a new list and add four instances of two cubes and two sphere user classes. When I type a refresh, nothing happens, of course, because this is hidden and this has no representation. So let's try to print these elements to the output. For this, we use function print, which is defined in the classes. Remark that the print function is defined in the cube as well as sphere class. So I can call it it's some kind something like virtual methods in C#. We call the same method for two different objects, two different classes. So this is very simple. We just print it out to the output and we see what's inside the list. Something more interesting for the introduction is combining the list with the link functions, which were presented before. Something is wrong. I will not think what is wrong. I will show the source. Here you can see the link combined with the list of user classes. For example, I calculate the sum of volumes of all these objects. So I call link function sum on the list and I convert each object to its volume. So this is a very simple example how we can calculate sum, average, minimum or maximum value or anything else from user classes, which can be very useful. You can define your user class which hold instance properties, instant values, and define the logic how to work with these properties and values and calculate the result which you want. For example, you can define cross-section which will provide you some data, characteristics, area, young modules, stiffness, moment of inertia, and so on and so on. Yeah? So that's something which can be used in your calculations, and this can be very effective and make the code much more readable and understandable, because the logic is at the same place as the instant properties, and it makes the code more readable. Is there any question to this initial example? Maybe one more remark. As you can see, the constructor of the user class contains one parameter. As you know, user class can contain several constructors. The first, or the default one without parameters, is generated automatically. You don't have to make it. If you need a constructor with parameters, then it must be defined in this way. We can make another constructor which would use, I don't know, something else, double something. Of course, this is nonsense in this case, but I want to just show you that you can define several constructors with various number of parameters. So if there is no question to this example, I will go to the second one, which is the usage of classes as a static object which hold references to fonts, pens, and can help you with preparation of tables and generally outputs. Here you can see the definition of simple class, which defines some numeric parameter which is not used. It's just for presentation. There is also two objects, black pen and font Arial. These properties are used in method prepare table, which is used to prepare the output table. As you can see, I create a table in standard way inside the function, set its properties, and return this as a result of this function. Then what I do with the class, I create an instance of that class and save this to the results under a member placeholder to make it available through all the member, all sections, all combinations. And that's it. Yeah. So in the master CLC, I just define the class and save it to the results. What I do in an external calculation, I read the class from the results, create a table using the function which we saw in the master, and fill it with some dummy data, of course, and draw the table. We see several exceptions here because in the standalone run, the results are not defined, so we would need to handle this exception that the result is not defined, but for presentation it's good enough. And as you can see in the master, when we save the my class to the results, it works properly. What's the benefit of this solution? We define the table on one place and we can reuse it all over the nested calculations. In all external calculations, you can use this function and define the table and of course any other object, graphics, graphs, whatever, fonts, at one place. We can try. Yeah, sorry, the rest of the master is very simple. As you can see, I simply read the external calculation and draw it. Yeah, it's quite simple. So let's try what happens if I change the definition of the table. So let's say we will want to change the color to, for example, red. And as you can see, the table is changed instantly. So we are able to handle the visual style of table in external calculations from the master. The small modification of this attitude can be defining this class in external calculation and load it in the master. Then of course it's one more level up. We can reuse this function in complete solution, reuse it in all master CLCs, and handle really all tables in all calculations, all master CLCs from one place. I hope you see it's much more effective to define table and stuff like that at one place rather than define it again and again at several places. For example, let's say we want to change default padding. So we simply type that padding all equals to 10. It's the initial value, so 50, and it works. Yeah. So really we handle the table from the one place. Is there any question to this technique? Is the combination of several techniques which were presented here at the SDF trainings before. We use UserClass, of course. We use save results, which saves it to IO structure, and function, of course. So it's just combining basic techniques and basic features to the one solution. Any question to that? Or maybe not a question, just an idea or note? If not, this is all for today's training. I have nothing else to show you today. So thank you for your attention and have a nice rest of the day. Bye bye.